Hello everyone, today we're going to look at usaco-training Raucous rockers. Alright, so in this problem we're given n songs and we're given a set of m discs where we can put some songs in them, and each disc can hold at most t minutes of music. And of course, you cannot split a song between two discs, so they must be either completely in one disc or completely not. So here are some rules. The first rule is that the songs must appear in the order of dates. So what it means here is that, let's just say we have these four songs. So then you cannot put four and four in a group if you're using three. Since if you're using three, it means that basically since let's just say that your first disc would use these two fours, okay? But then since they must appear in the same order, then your next disc must start at two, so you cannot kind of overlap the disc. And then what we want to do is that we want to maximize the total number of songs that are going to be used. So over here we're given four songs, and the maximum number of minutes is 5, and we're given two discs. Two discs. And song number 1 has 4 minutes, song number 2 has 3, song number 3 has 4, and song number 4 has 2. So then we just print the maximum number of songs that can fit in M discs. So over here, it would be optimal to use both discs. So the first disc would use 4 over here, and then the second disc would use 3 and 2. So then you have a total of 3 songs, and it does follow the rules since they're in the order, and that's about it. So we just print out 3. Right. So the observation here is that n, m, and t are less than or equal to 20. So what we can do here is that we can run a complete search. Search RCH. Alright, so we're just going to run a complete search. So at each state, what we're going to store is that our current song. We're also going to store the number of songs we used. So number of songs used. And then we also have to keep track of the number of discs used. So number of discs used, and basically besides that, we also have to keep track of the number, or the we also have to keep track of the size of our current disk. So current disk size. All right. So these are basically the 4 states. So then so right now we're just considering this current song. So we can either, 1, we cannot use this. 2, we can continue it from our current disk. So basically append it. And 3, we can also consider to make a new disk containing, or we actually don't have to write this. So we're just going to make a new disk containing our current song. So then what the states that are going to be created. So if we do not use, let's call this, we're going to result in search let's call this I, and let's call this number of song used. Let's call this N. This let's call this or IJKL. Okay, so I, whoops. Alright, so here IJKL. So if we do not use the current song, then we're going to search I plus 1. We're going to retain the number of songs used since we're not adding a song. And the number of this would stay the same, so would the number of, or the disk size. So if we're appending it to the current disk, whoops, then it's going to be search. Again, it's still going to be I plus 1. For J, we're going to, since we're using the song, so we're going to have to increment that by 1. And the number of disks would stay the same since we're appending it to our current disk. And then our disk size, which is L, we would add basically the size of I, since we're appending it to our disk size. And if we're making a new disk, then this is going to be search. Again, I plus 1 since we're moving on. Again, we're using an extra and extra song, so we have to increment J by 1. And for K, since we're making a new disk, then we have to also increment this by 1. And then our size, or our new disk size, would be the size of your current song. So then, now you basically know, like, your transitions. Alright, so then, like, when you know how to stop and, basically, when you want to terminate your search. Okay, so let's write using this in red. Okay, so we have to watch out for a few things. So if K is greater than M, which means that you have exceeded the number of disks, then you cannot use this since we're only limited to M disks. So we're just going to, let's just basically cases to terminate. So one case, as I said before, is if K is greater than M. Also, if the current disk size is greater than T, which means that you cannot fit this many songs in the disk. So in these cases, we're going to return. And now the last thing we need to do is, like, when do we update our answer? Like, when do we relax our answer? So to calculate our answer, we have to make sure that we're done with everything. So we're done with all the N disks, so we make sure that we include anything. So then over here, what you'll notice is that every time after we calculate it for the ith disk, we're going to move on to I plus 1. So then when we're done with the nth disk, then we're going to move on to n plus 1. So then it's going to be if I is equal to n plus 1, then our answer, we would just, since you want the minimum or maximum actually, answer and the number of songs used, which is going to be J. So then J. Right. So over here, the key idea is that you notice that you can run a complete search on this. So then you just have to finalize your state, and then you have to make your transitions. And the thing is that sometimes complete search can be pretty slow, so you have to make sure that you have cases where you terminate, so it can basically speed up your program. All right. So that's it, and let's get coding. So let's put that over here. Let's get a template. Alright. So then we have N, T, and M. So N, T, M. Alright, so then over here we're going to read in our size. So let's call this SC, and let's just give this 30. So we're just going to, for each of those things, we're going to read in the element. So now we're just going to make a search. Let's call this DFS. So here we need to make our function. So we have I, J, K, and L. Alright, so over here, what we need to do is that we need to basically call this function. So we're going to start off at the first song. The total number of songs we use is going to be 0. The number of discs used is going to be 1, since what we're going to do is that we have to kind of like increase this. So this is going to be 1, and the current disk size is going to be 0. Alright, so over here, if K, which is the number of disks, is greater than M, we have to return. Or if L, which is the disk size, is greater than T, then we have to also return. So then, if I is equal to M plus 1, then we need to relax our answer so we can have your answer. And since you want your maximum, so it would be max answer and J, which is the number of disks used. And after this, you want to return. Otherwise, we can consider either not using it, appending it to our current disk, or just creating a new disk and putting the song on it. So then, if we're not using it, then it's going to be DFS I plus 1 JKL, not using. Okay, so if we're appending it, again, we're moving on to I plus 1. We have to increment J by 1. K over here, which is going to be the number of disks, is going to stay the same since we're appending it. And L over here, you would add the size of your I. So appending it to current disk. Alright, so the other choice is to create a new disk. So this is going to be I plus 1, J plus 1, K plus 1, because we're creating a new disk, so you must increment the number of disks. And then the last thing is going to be size of I. So creating a new disk. Alright, so let's run that and let's printf our answer. Alright, so let's run this. Alright, so over here we have this. Alright. 3, very nice. Let's submit this. Rockers.in, rockers.out. Alright, so let's get over here and let's submit this. Alright, so other okay here, and alright, rockers. Ooh, okay. Why do I always make a typo? Literally every time I make a typo on this free open thing. Alright, that's fine. Let's submit it again. Okay. Alright, everything is correct. If you have any questions, feel free to leave them in the comment section below. Thank you. Bye.